question, dy by dx is given and 2 points on the curve are given, and we have to find the equation of the curve. So to find equation of the curve from dy by dx, we integrate. So we integrate with respect to dx. Left-hand side just becomes y. The right-hand side is actually minus k x power minus 3. And the coefficient can be taken outside of the integral. So we write minus k here. Just give me a second. Okay, sorry about that. I got a call. Okay, so minus k stays the same. Integrate x power minus 3. This would become x power minus 3 plus 1, and same minus 3 plus 1 in the denominator, and plus c with the answer. So we're getting y equals minus k x power minus 2 upon minus 2. And when we simplify this, we get k upon 2x squared plus c. Okay. Now we have to find the value of k and the value of c. For that, we're going to use these two coordinates given to us. Let's substitute the value of x and y in this equation. Okay, so y is 18. Writing 18 is equals to k upon 2. 1 squared is just going to be 2 plus c. Now I'm going to rearrange this. I'm going to take LCM. So k plus 2c upon 2. And now I'm going to send the 2 to the other side. Gets multiplied with 18. So we get 36. This should be equation number 1. Equation 1. Similarly, now I'm going to replace y with 3 and x with 4. So I get 2 times 4 squared. That would be 16 times 2, which is 32. Plus c. Now we take LCM again. So that's going to be, let me do that here. 32 k plus 32c, and send 32 to the other side. It gets multiplied with 3. That's going to be 96. This is equation number 2. Now we solve these equations simultaneously. Let me write 96 is equals to k plus 32c here. You can use elimination method or substitution method. I think elimination would be easy here if we replace this with minus, this with minus, this with minus. So now k and minus k gets cancelled. K has been eliminated. We have minus 30c here, and we have minus 60 here, which gives us c equals 2. Once we have c, oops, just a second. Yeah, once we have c, now we can find k by substituting it in either one of these equations. Let's use the first one. So I'm going to do 36 is equals to k plus 2 times 2 is 4. This gives us k is equals to 32. So the equation of the curve becomes y equals 32 upon 2x squared plus 2, which is y equals 16 upon x squared plus 2. Find the area of the shaded region. Now this is a question on integration. So the curve is being integrated within the limits 1 to 1.6. So we integrate the curve from 1 to 1.6, and the curve is 16 power x minus 2 plus 2, and we write dx here. Let's integrate. We get 16x What is minus 2 plus 1? It is minus 1. Also minus 1 in the denominator. Plus integration of 2 is 2x. When we have limits of integration, that is when we have definite integral, we do not have to write plus c. So no plus c now, and these are the limits. So now let's substitute the values. Let me simplify this and write this is actually negative 16 by x. Let me write that instead. So this would be, first let's substitute 1.6, then subtract and substitute 1 here. Okay, so when we substitute 1.6, so we have negative 16 upon 1.6 plus 2 times 1.6, that's giving me negative 6.8. Now substitute 1. So negative 16 upon 1 plus 2, that's giving me negative 14. So we have minus 6.8 plus 14, that comes out to be 7.2, which is the correct answer for the area of the shaded region.